Hello, ladies and gentlemen. Yeah, just first of all, I'd like to thank 12D for allowing myself and Jarred to speak here. So, sorry. Today, we're going to speak about complete design documentation on Parramatta Light Rail project. So, myself and Niall Brady, I'm the digital engineering lead for Arup in the Sydney office, and here we have Jarred. Say hello. Jarred Dickson. So he's a senior engineer from the highways team in Sydney. Just up. So, as you said, today we're going to present the Parramatta Light Rail project. So, we're going to basically go over this rough content. So, we're going to look at project details, what is digital engineering, and then I'm going to move you on to Jarred, who's going to talk about digital engineering in 12D using smart snippets and smart chains. And then moving on to automated road furniture using line marking, curbs, and traffic signs. And then design verification, aquaplaning, swept paths, and sightlines. And then moving back on to me, who'll finish up with utility coordination using the survey specification, a utility schema, clash detection, and then finishing up on the federated models, design documentation, stakeholder engagement. So first of all, the kind of project details. So the client for the project was Transport for New South Wales. The project is stage 1 of the Parramatta Light Rail, and it connects Westmead to Carlingford via the Parramatta CBD and Camellia. It's a two-way track spanning roughly 12 kilometres and on and offline, so through urban streets as well as offline sections. It's due to open in 2023 and an estimated cost of $2 billion for stage 1. The scheme is currently in the tender review period, so complete award in a few months' time. And stage 2 has been announced and it's in the early design stages as well. So in terms of the project, so Parramatta is basically west of Sydney, and the areas we're looking at today are some early works. Enabling works packages. So the first one we have is section 1 and section 2, which is along Church Street and O'Connell Street, which is basically moving traffic off the existing Church Street onto O'Connell Street to allow for the construction of the light rail up Church Street. We've basically section 3 along George Street, which moves the traffic from Macquarie Street onto George Street, changing George Street from a one-way, two-lane to a two-way, one lane in each direction. And we also have another section along Hawkesbury Road, which is adjacent to the upgraded Westmead Hospital. So in terms of the client and what they actually wanted from us, so basically they wanted all 3 enabling works packages delivered in 16 weeks, so a very, very quick turnaround. That was to enable them to get these off to a contractor to be constructed before the main works commenced. They also wanted to apply a high level of digital engineering on the project and develop a 3D model and basically apply work breakdown structure and naming to enable 4D, 5D and 6D BIM. So that'll be asset management, and I can explain what that is next slide, as well as use the model for design coordination and stakeholder engagement. So what actually is digital engineering? It does seem to be a buzzword kind of going around for the last few years, but I'll try and explain it, or what Transport define it as. So digital engineering is simply a collaborative way of working using digital processes to enable more productive method of planning, designing, constructing, operating, and maintaining our assets. This is achieved by creating a common data environment, a CDE, that aligns digital information systems, including CAD controls, so time, cost, risk, etc., asset data, and other related systems. So this kind of diagram shows where you have your 3D model, which then linked to the 4D model, which would be like your Microsoft project, then linking back to your cost, which would be like cost X, and then linking to your asset data at the very end of the project and handover. And then you also have other systems like 2D and 3D GIS, document management systems, risk management, require management, and etc. So I'm now going to pass you on to Jarred, who's going to talk about digital engineering in 12D.
Thanks, Niall. So I guess as Niall's already discussed, one of the main constraints was the time frame that we actually had to deliver the project in. So I'm going to talk about a few of the design tools that the road design team used just to, I guess, reduce the amount of rework or reduce the amount of documentation or anything like that, and ideally get the design right first go. So one of the obvious things that we used was snippets, or smart snippets. So we had snippets for carriageways, barriers, curbs, pavements, retaining walls, all those sorts of things. I guess the idea being is that we tried to limit the amount of inputs or the manual inputs into the snippets that could result in errors. So the snippets had all the code embedded in or hard-coded into the snippet, or it referenced project details or project attributes or something like that, and then that way there was consistency across the project. The design models were consistent, obviously meant the output models were consistent, and obvious benefits from that. In addition to the design elements, we also had other snippets that were doing things like the vertical clearance envelopes. So you probably saw an example of that yesterday. We had our own version of it. We also had things like modelling the clear zones within 12D. So that obviously meant that we could design barriers on the fly. We didn't need to do any sort of review process afterwards. Other disciplines were also using those outputs. So like the clear zone outputs went straight to the landscaping team. So they knew instantly where they could and couldn't plant different species of trees, or it had to be trees or shrubs or differences like that. Also the snippets too, they were embedding attributes into, or in the background they're embedding attributes into all the trimeshes and things like that were being created. So then when we sent IFC models out to other packages, so like building structures or civil structures or something like that, they could interpret our design straight away. They didn't need to be asking us questions or anything like that. They knew exactly what they were looking at. Obviously just sped up design time, sped up the coordination between disciplines. Another obvious one is smart chains. So again, we had one source or one chain that would effectively run multiple times, taking advantage of the parameter files. This meant that we could obviously make tweaks to outputs easily and then get consistent outputs across disciplines or across packages or that sort of thing. We took that a little bit further as well, and rather than using chains with parameters, we actually made macros. So rather than needing to skill people up on actually what parameter files were or how to use them, they were given a macro which had a friendly user graphical interface where they could put the values in and keep going. So again, speeding up time, speeding up the documentation. And so one of the things that we found is that we always spent a lot of time at the back end of projects actually I guess doing the documentation, the sort of things that get shoved into the back of reports and don't really ever get looked at but need to be there. And so we wanted to sort of do all that sort of stuff on the fly, and then that way we didn't have that period at the end of the project that we had to go back and do all the checks and all that sort of thing was already done. So we had a whole bunch of macros that helped us with that sort of thing. And one of the main macros that we were using was this signage, dynamic signage macro. And the way that it worked was basically there was a spreadsheet database which was populated right at the start with a few manual inputs, all the basic manual inputs, so things like a control line name, a chainage, an offset, a sign type, that sort of thing. Within 12D, macro read this spreadsheet and filled out the rest of the, pre-populated the rest of the values, so like sign sizes, pole heights, footing depths, all that sort of thing. The macro, once it read all that sort of stuff in, it then went and created a whole bunch of stuff in 12D. Things like it actually created the true size trimesh of the sign, so you knew the physical extents of it within 12D instantly. It created a 2D scalable block, 2D scalable labels, all that sort of thing. So again, that went back out to 12D, out of 12D, and there was no manual CAD work or anything like that to actually label the signs or present it. It was already done via the macro. Obviously sped up scheduling, sped up time, all that sort of stuff. The other benefit of the macro as well is it went two ways. So once you had that 3D true scale, true size block within 12D, you can go and move it or go and update the register within 12D, and then 12D would overwrite the spreadsheet back again. So you could do both the design within 12D and outside of 12D. Very handy. So I guess here's just a couple of different screenshots of it showing that you can see both the spreadsheet there within 12D. The macro also created a whole bunch of attributes again, so if the signed or if the trimeshes went back out of 12D, you can instantly see what the trimesh was about. Just another good visualization or screenshot there of how it all looked once it all came together. Another thing that our snippets were doing was trying to automate scheduling, like I said. So particularly used that for the road furniture items. So things like all the line marking, all the delineation, arrows, symbols, all that sort of stuff. Spoke about the signage that was just there again. curbs, barriers, all that sort of stuff. So the snippets in the background that are applying all these attributes, applying all data to what was being created in addition to just the design strings or design links, and then that way we could automate scheduling. So if the design change, schedules happened automatically, and there was no need to have someone sitting down and adding up all the lengths or doing all the quantifying themselves. And we could easily add all the annotation within 12D. Another one, like I said, we're trying to speed up and do all the conformance checks and all the conformance documentation on the fly rather than leaving it right to the end. So made a tweak to the aquaplaning macro, which effectively, rather than having to go and manually draw the flow path, it draws a flow path dynamically as to where your cursor is located over the screen. So as you were to move your cursor along, it automatically moves the flow path along. You find the one that you're happy with, you click OK and accept it, and then the macro will automatically apply attributes onto that string showing all of your aquaplaning risk data. So again, it doesn't have to go out of 12D to review it. You can do it in 12D on the fly, and if it's wrong, obviously make changes to your design straight away. It also, again, we're trying to go into the 3D world with IFCs and Trimeshes, so it automatically made a 3D version of the flow path as well, so you can send that out to other packages and they can instantly see too where all the critical areas are that we've been looking at. Again, to reduce documentation, that macro, as soon as you accept a line and accept OK, it automatically does a PDF plot for you, so you can tuck that away neatly in the back of your report without having to spend any more time on it. Again, another thing that we found we spent a lot of time on was swept paths. So another macro that was developed, again, sourcing from an external spreadsheet. So you'd have someone go through and populate all the intersection names, all your design parameters, all that sort of stuff. Two-step phase with the macros, that it'd read that spreadsheet in. It'd then go and create all your super alignment, all your turn path functions and all that sort of stuff within 12D with very little need to make any edits or tweaks to it, because all of the base data is already filled out in that register that you knew that you're going to have to check before you even do the checks. That macro then goes and does a plot instantly again, so you can tuck it away in the back of the spreadsheet. It also creates a 3D visualization or 3D trimesh of the turn path itself. One of the main concerns that the client had was being in a constrained CBD environment. A lot of the surrounding buildings had awnings that spread over or occupied most of the footways, and so one of the main concerns that the client had was whether or not heavy vehicles using curbside lanes are actually going to clash with the awnings. So it was handy to have these visual checks of the turn paths to show on the fly within 12D that there wasn't an issue at all. We didn't need to produce any more documentation on it. So that's just an example of one of the plots that came straight out of 12D, showing the turn path that didn't have any sort of manual input to it really at all, rather than filling out that register right at the start. Just another handy little view shot of what the actual 3D envelopes looked like. Again, another example is all the sightline checks. So had a macro that would go through, you'd put in all your parameters as to what sort of intersection sightlines you're actually needing to check. It'd go and create a computated super alignment for you and instantly, again, work out if it fails based on intersections with tins or intersections with obstruction models such as trimeshes or that sort of thing. And to create some of those obstruction models, we had a macro which would go through and map your 3D survey model to actual 3D objects. So all your point strings, things like trees, poles, other elements such as your road furniture like bus stops, bins, anything like that, that's actually just generally picked up as a point string from your survey model. The macro would go through and map that to an actual 3D trimesh object in 12D, so you could easily put that into your sightlines and work out if it's actually an issue or not. The macro would also create a perspective view for you, starting at obviously your eye position and then your object position. So again, we could visually show the client on screen here that whether or not it was an issue, and benefits of that again was that we're just reducing documentation at the end of the project. Another one that we found really handy that we developed up in-house was the HGL to Trimesh. So again, taking the network that's been modelled for the drainage editor, it'd go and show the water levels in the pits, in the pipes, all that sort of thing. It's a Trimesh, so you can obviously turn it on in sections, turn it on in perspective view, and get a pretty good idea straight away as whether or not there's going to be design issues. So I'll pass it back to Niall now.
Thanks very much, Jarred. Yeah, now I'm just going to finish up and go through some of the utility stuff we've done. So utilities, especially in a kind of inner city environments, obviously very, very critical. Can be major high risk on projects. A classic example is Sydney Light Rail, which is currently going through the courts because of utilities. So with kind of transport and some other of our consultants, we kind of sat down and basically kind of went to try and set up a better process of doing this. So we basically developed a utility schema, which basically listed out all kind of standardized attributes. We basically had a utility specification that then basically both of them documents fed into basically the dial before you dig and kind of surveyed information to basically get a standardized approach in terms of naming. So they all fed into a 12DA file, which then was used to populate the Navisworks model, the GIS portal, and basically the 12D model. And then for the Navisworks model, we can basically start and look at the utility model, the architectural model, the structures and the civil model, as well as in the design space. We actually looked at the utilities, the rail, the drainage and the road. But all this information was coming from one source, so basically one point of truth, as you will. So basically that'll be the 12D file, and then basically all your design would be in the 12D, and then all the coordination and clash detection we were doing in the Navisworks model. So the utility schema was largely at the start was based on the Australian standard 5488, which was a classification of subsurface utilities. So that's just an extract that you can see there at the table on the right hand side. And then from that, we basically added additional attributes to basically standardize the setup and of the GIS system, the 12D mapping, so your long cross sections, as well as the federated model properties. So every utility had roughly around 70 different attributes for type, clash, and then we also added in the kind of risk and the kind of treatment going forward, whether it would be concrete protection, removed, abandoned, whatever it was. So the utility schema basically looked like this here. So as I said, this is obviously just a snapshot, but there is around 70 different attributes on these from various different areas. So the workflow we actually went through for this was, first of all, we went through and digitized up the dial before you dig data in 12D. Bit of a pain process, but we tried to get a lot of this from GIS and kind of convert it across just to reduce the actual manual input. We then went and actually identified any additional survey needed and actually sent that out for additional survey and potholing, which the surveyors came back with. And we asked them to provide a 12DA file with the attributes already applied. We also then applied a unique ID, which we are calling the Go ID, using basically a macro. So the macro basically picked the model, assigned an individual identifier to each string or each point, and then basically we had another macro set up where you could actually jump to that unique ID as well, just for ease of kind of checking the data. We then applied attributes using a string filter. So let's say that's a classic one like your quality level D, and that was basically from the name of the model. We then applied the remaining attributes from the register. So this is just a snapshot of the register and just some of the attributes applied. So yeah, again, a very standardized approach. And then we also applied the actual size of the pits and the pipes using actually the attribute string and the size from there. And then obviously before we actually applied reapplied the register, as in it's a back and forward process, we actually ran the attribute manipulator file just to clean out the data rather than doubling up on the attribute strings themselves. And yeah, then sorry, that's the pipe size one in there. And excuse me, and we also built up what we called an Arup utility inquirer. So I think you've probably seen some of the stuff yesterday, where we had a customized thing basically for all the attributes we set up. So whenever we actually selected a string, you didn't have to go into the long properties attributes. You could just basically see all the information there, as you can see. And again, all this was kind of automated in a kind of standardized chain. And then once it was all done, it was exported to IFC, GIS, and the kind of federated models. So here's just a snapshot of the information within the 12D model. So you can see here when you select a string, you can have the properties on it in both plan and lawn section, and you can see the actual pipe size. And then if we take that forward, we can see the exact same information in the GIS portal and in Navisworks itself. So that was the power of using 12D in this way. We had the same information across all platforms. Within there, we are also able to do some clash detection. So you can see there, so we basically sorted out if it was a hard clash or a soft clash by using standardized rules. and then within there we could actually report back on the actual clash. And you can see there where we actually got the 12D Go ID actually in the clash report, so then we can go back and check that within the model and the GIS platform. And again, ultimately our deliverable was to deliver a full set of paper drawings, or PDF drawings even. So you can see here's an example of our long and cross section, and you can see some of the, we have basically the utility type, the quality level, and the estimated invert level on both plan and cross. But obviously, when we're providing this information to contractors, it's very, very important to caveat it. So we said the contractor had to confirm all the information, and the utility model we did provide them was for information only. And just here's an example of our kind of GIS platform. So this was actually an online platform, though you didn't need any software. You could just go on, click on the utility portal, and actually review the utilities on there, and then report it back for the designers to amend or tweak kind of treatments and things like that. And we did give access to the contractor, and even like some of the authorities wanted access to this as well. So a very, very good message. Just the last topic today, just how we basically federated all these different file types together. So here, it was one of the sections on Hawkesbury Road, where we basically had a number of different consultancies as well as disciplines. So we had road design by others, drainage by others, we had obviously utilities I just spoke about. We had basically a civil structural package that came from Revit, as well as the building, the architect, and landscape architect as well. So we'll be able to basically bring them all together in 12D. So basically do our review and do our design and basically make it all fit together. So you can see there, that's just a section along the road. You can see massive rock bolts. You can even see our landscaping, and then basically the 12D design on the road as well. And then the same, we can basically look at this. This is again just from the 12D itself, just a few more snapshots of the model you can see. And then if you take it back, we can export all our files as an IFC file out to Navisworks. So you can see here, so the classic example is you can see some of the shear utilities along the corridor, and you can see kind of what Jarred spoke about with the traffic signs macro. We were able to put in the foundations of all the posts as well, and you can actually see some of the clashes there, so some of them things were removed afterwards. Then you see landscaping, all our pavement, all fully modelled there, as well as cutting sections through the structure. So just to finish up, so yes, we actually delivered this entire project in the agreed deadline of 16 weeks. We delivered the 3D model with attributes for 4, 5, and 6D. We had also a full set of drawings for all disciplines, and this was done with a relatively small team of 3 engineers, 1 designer, and 1 CAD person at the end. And by kind of using the model in our stakeholder engagement and speaking to like our client RMS and transport, we actually agreed loosely, not 100% just yet, on some of the departures, like the classic one where Jarred was showing the sight line for the trees, where you can clearly see the tree is actually within the sight line, but they wanted to create this boulevard effect, so we could actually see what you could actually see by placing the cars on the road itself as well. And overall, we could not achieve this without adopting 12D and digital engineering processes. So thank you very much. And if you have any questions, yeah, come see myself or Jarred later. Thank you.